If you decide to use variants in your embedded code, there are 4 different points in time where you can decide which type of variant you want to use. My name is Wolfgang from Stuttgart, and I'm here in the sunny Bangalore together with my colleague Markus.
Yeah, Wolfgang. And what are these 4 variants? Especially, I think we talk about a model-based development approach, right?
Yes, we can say we can freeze this in different times, and of course we talk about model-based development. And this can be done on the model level or in the code level, or we can do it during compilation time or finally at runtime. And each of these different decisions have different implications.
Okay, let's first talk about freezing the variant during modeling time. It means for each variant we have a different model. Then obviously if we generate code, we have a different code. And then for each variant we will also have a different test project. And this can be efficient if you have like big difference between variants, but it can also have a negative impact on the maintainability of the test cases and also make it maybe more difficult if you want to reuse the test case between the variants.
Yes, so maybe not always the best approach, but if we do the freezing at the code generation time, then we only have one model, but we have for each variant a separate version of the code. And this means you can test all variants on the model level, but of course you must test them separately on the code level. And this also means if you run a back-to-back test, you have to do this with each code version separately, which can have or run into problems if you have huge interface differences, and then the test data must be adapted accordingly.
Yes, and now let's look at option 3. If we freeze the code variant during compilation, it means we have all the variants in one single model, we have all the variants in one single code file, but during the compilation we would use so-called preprocessor macros that will then tell the compiler that only one variant should end up in a specific object code. But this brings a lot of challenges for testing. Handling code coverage is not easy. Debugging is not easy because if you look at this, we could say what you see is not what you get. Okay, because if you look at code coverage, if you look at debugging, you obviously do not read the object code. Right? People don't do this anymore. You look at the C code, but the C code is different from what is executed on the object code level. So you will see lines of code, and it's hard to figure out if they are really part of the object code that you're looking at. So this can be confusing, especially if you have a more complex setup for the variants.
Well, and there's a 4th way how we can handle this, and this is to decide this at runtime. This means we use the calibration data to decide between the different variants, which also means we have one model version, we have one code version, we have one compiled version of the code. So we can test all the different variants by changing the calibration data within this one model code, so we can make comprehensive code coverage analysis, model coverage analysis, and then we have everything in one test project to get a full report of this.
Yeah, that sounds like the most convenient option from a test perspective, but it also would mean that it can have an impact on the resource consumption of your production code. Yeah. So to summarize, we can say that every one of these 4 variants has its own advantages and disadvantages, but you should really be aware of the impact that these decisions have on your test process.
Thanks, Markus. So if you found this video useful and informative, follow us on YouTube and LinkedIn, or follow us on our webpage to get more information. See you. Bye.